Section 4.2, Graph of Rational Functions, Math 110. Here is a summary of what we're required to do on these sections. That if you have a rational equation, again, rational equation is the one that has a denominator and there's an x or any other variable at the denominator. We need to find the domain, we need to find x and y intercept, and finally sketch the graph. But I'll show you all this by going over the examples. There are some good examples in the book. One is the first one. You have, this is on page 319 of your textbook. Sketch the graph. When you have equations, what's the main difference between these two equations? Let's say one is y equal x plus 1, and the other one is y equal like 3 over x plus 3, something like that. Domain is x. That's what domain is. And range is the y value. Now, question is, can we take any arbitrary number and substitute for x, and we always come up with the value of y? In this case, since there is no denominator, yes, you could come up with any numbers, any arbitrary numbers for x, and when you substitute, you have your y. It doesn't matter whether it's a positive or negative, or even 0, and you always have a value. That's not the case for a rational function. Why? Because it's rational, because there is an x at the denominator. So in this case, for instance, if I substitute 0, 0 is fine. You substitute 0 here, y is 1. Or you substitute a negative number, let's say negative 1, that's fine. You put a negative 1 here, so that would be negative 1 plus 3 is 2, and 3.5 or 1.5. There is only one number that you cannot substitute for x, and that number is negative 3. Why? When I substitute negative 3 here for x, then that negative 3 makes the denominator 0, and 3 over 0 is undefined. You could always use your calculator. On your calculator, you just put, okay, what is 3 divided by 0? See, the calculator would give you error. Anytime you have a fraction, the denominator is 0 is undefined. So for rational fraction, for you to define the domain is all the numbers except a number that make the denominator 0. How do I find that number? Just take the denominator, set it equal 0. That gives you the number that you're looking for. Another example, let's say I have something like this, y equal x over x plus 5. It doesn't matter what the numerator is. What number would make the denominator 0? Take x plus 5 and set it equal to 0. X negative 5, that's the number that would make the denominator 0. So you don't want that. So when you want to define the domain, just say all the numbers except 5. That number also would give you the vertical asymptote. So when you take the denominator, you set it equal 0, you find the domain, is all the numbers except that, and also that would give you the vertical asymptote. What if you have something like this? You have, I don't know, y equal x plus 1 or x minus 3 times x plus 7. Look at this one. Two numbers are not at the denominator. X equal 3, x equal negative 7. These are the numbers that you don't want it. Domain is all the numbers except these two. However, these two also give you vertical asymptotes. We ask about the vertical asymptotes. Those are vertical asymptote, x equal 3 and x equal 7, that we are going to discuss here. All right. So on this one, you see, x equal 2, is your vertical asymptote. What is vertical asymptote? Is where the function is disconnected. Function is cut at x equal to, means it goes all the way to minus infinity and goes all the way to positive infinity. So that's the line that cut your graph, is a vertical asymptote. We also have a horizontal asymptote, but there are three cases on horizontal asymptote. One is if you're, let's say you have something like this. To find the horizontal asymptote, there are three scenarios. One is if the power, highest power of x at the top and highest power of x at the bottom, if these two are equal, then you take these coefficients and divide. So your asymptote is y equal 5. Means if you want to graph that, 1, 2, 3, 4, 5, this is your asymptote, horizontal asymptote at 5. Let's say you have another one like y equal minus x2 plus 3x, and then over there you have 2x2 minus x plus 7, something like that. Again, the highest power of x are equal. In that case, you take this number, which if you don't see any number is always 1. So what is your horizontal asymptote? Minus 0.5. Now, what if the power at the top is lower than the one at the bottom? If this one is lower, then y equals 0, or x-axis is your horizontal asymptote, which is this, x-axis. The third is, what if the top one is greater than the bottom one? If the power at the top is greater than bottom, in that case, you don't have horizontal asymptote. You have a slant, they call it, a slant asymptote. And we are going to talk about this later on. I'll show you some examples. So there are three scenarios. The highest power are equal. In that case, you take the coefficients and divide. The power at the top is less, then in that case, x-axis or y equals 0, which is this line, is always your asymptote. Like if you have a graph cannot cut this one. You cannot go through it. And the third scenario is when the top is lower than the bottom. So here, x equal 2 is 1. And remember, it's 3 over x minus 2. Do you see any x here? You could always write it like that. No, it is this, right? You could write it if you want as, any number to power of 0 is always 1. You could put x equals 0 if you want, because x to the power of 0 is 1. Now look, the power at the top is 0, at the bottom is 1. When the power at the top is less than power at the bottom, then it's this one. So x-axis is your horizontal asymptote, correct? So in that case, do you see this? This is your horizontal asymptote. You see how the graph do not cut the x-axis? It's parallel to this and it's parallel to that. So there are two asymptotes here. One is horizontal, which is the x-axis. The other one is x equal 2. Okay. And then how do I find the x-intercept? X-intercept is when you put 0 for x, you have to find a y. And how do I find a y-intercept? When y equals 0, when y equals 0, you cannot get any value here, right? See, if here, if 3x minus 2 is equal to 0, means if y equal to 0, when you cross multiply, what do you get? 3 equals 0. That's not possible, right? So you don't have any x-intercept. And you can actually see that. Our graph cannot intersect the x-axis anyway. So there is no, what is it? There is no x-intercept, right? But there is a y-intercept, minus 3.5, which is what? Which is this point. So my graph intersects the y-axis at this point. That's why it's minus 1.5. In this example, you take the denominator equal to 0. All the numbers are domain except 0. Because if you put a 0 here, this is undefined. Domain is all the numbers except this. Now, how do you find the x-intercept? The x-intercept when you put 0 here is minus 1 over 0, which is undefined. Okay, so there are only one asymptote, and that is x equals 0. What is x equals 0? Is the y-axis. So remember, to find the vertical asymptote, you have to take the denominator and set it equals 0. X equals 0. X equals 0 is the y-axis. So this is your vertical asymptote. How do I find the other asymptote? Look, the power of x is 1 and the power of x is 1. So 1 and 1 equals, so y equals 2 over 1 over 2. This is your horizontal asymptote. See, the graph goes from one asymptote to the other ones. Your graph must not intercept the asymptotes. See, it's from one asymptote goes to the other one, from this goes to that. How do I find the domain? Take the denominator, set it equal 0. You could factor the denominator is this, right? So two numbers would make the denominator 0, -1 and +2. These are also your asymptotes. Look, -1 and 2. These are your vertical asymptotes, okay? Now, how do I find the other asymptote? The power of x at the top is 1, at the bottom is 2. In that case, your horizontal asymptote is x-axis. Now, these problems, you understand that if we factor the top, x2 minus 9, this is a formula. If you have a2 minus b2, if you have difference of two perfect square is a minus b times a plus b, we are using that here because x2 minus 3 to power of 2. x2 minus 3 to power of 2 is x minus 3 times x plus 3, x minus 3 times x plus 3. You could cancel it, but if we ask you for asymptote, you must cancel it, and then you just say the asymptote is what? X equal -1, because you have to take the denominator equal to 0, right? And then you say your asymptote is -1, which is this. But for domain, you have to consider both numbers when you ask for the domain. Okay, they did ask for domain, but if you ask for the domain here, domain is 3 and -1, which when we look at some examples on your homework, they ask also for domain, they didn't ask for domain. Okay. This is an example that when the power of x at the top is greater than power of x at the bottom, then your asymptote is a slant asymptote. And they show you how to find it by dividing these two. By dividing these two, that gives you the asymptote that I'll show you in the examples how we find this. Okay, same thing. All right, so the first homework, the first few homeworks are all about translations. You remember, if you have a function plus a number, if that number is positive, you shift the function up, and if it's negative, you shift it down. The function is 5 over x. This is given. Okay. They want you to find this function plus 2. Plus 2 means if the number is not within, is not associated with this function, is always translation to on y-axis up. So what's the difference between two? You take the whole function and shift it up 2 units. When you shift it up, you come up with this. If you have a functions like f of x and we ask you to find minus f of x, I'll show you an example here. One of the good examples is this. What's the difference between y equal x2 and y equal minus x2? When you have minus x2, you kind of flip this. When you flip this, if on respect to x-axis, with respect to x-axis, when you flip it, that would be minus x2. So what I do is, if this is 2 over x, right? When you flip this, means this one would go here, and this one would go there. You see that? What is reflection of this piece with respect to x-axis? You flipped it. What's the reflection of this piece with respect to x? You flipped it. Goes up. This is very similar to the other one. A is negative, right? So you got to shift it down. You got to shift the whole thing down on the y-axis. See, you shift the whole thing down on the y-axis. If the number is within the parentheses, then shift is on the x-axis, on the opposite of these numbers. Example, y equal x2 is like this. What about y x minus 3 to power of 2? My opposite of minus 3 is positive 3, means you got to shift this on the x-axis 3 units to the right. So always opposite of that number, shift is on x-axis. So here you had 3 over x2, right? But in the parentheses, you have x minus 6. Shift has to be positive 6 on the x-axis. On the x-axis, you take the whole thing and move it to the right. To get that. Again, what is the shift when it's in the parentheses? Opposite of 4 on the x-axis. Opposite of 4 is negative 4. You get these functions, you shift it to the left 4 units. It's always opposite of these numbers. 4 shift on the x-axis is negative 4. The whole thing moved to the left. Again, this is similar to the one we were talking about. Remember I said, what's the difference between x2 and minus x2? It would be shift. You flipped it, not the shift, you flipped it with respect to x. So the whole thing would flip. This could be like that. Okay, and this goes like that. See, this piece would be that. You flipped it. This piece, you flipped it up. I mean, you find the symmetric to respect to x-axis. It goes to the top. All right, now we go through these problems. First, they ask you to find the domain. To find the domain, you just take the denominator, you set it equals 0. You set all the numbers except that one. Okay. How do I find the x and y intercept? Anytime you want to find x and y intercept, draw the table. Once put 0 for x, find the y, or 0 for y, find the x. All right. So I show it to you. If you put x equals 0 here, then it's 1 over 5. But if y equals 0, then you have this. If y is equal to 0, means you have 0 over 1. When you cross multiply 0, it cannot be equal to 1, so that it doesn't exist. Okay? So when y is 0, you cannot find the axis. Now, one of the asymptote is x equal -5, which is the vertical asymptote. This is vertical asymptote. X equal to, oh, this is not a right graph, but X equals -5 is your vertical asymptotes, okay? Now, how do I find the other one? Again, your function is 1. Let's say is x to the power of 0. The bottom is x1. Remember, if the power is less, then x-axis is your asymptote. So that's why here, your horizontal asymptote is this one, is x-axis. See, the function is parallel to this, but it doesn't intersect it, right? Just goes all the way like that. It's parallel to that. How do I find the domain? Take the denominator, set it equal to 0, all the numbers except that. It's very similar to that. How do you find the intercept? If you put 0 here for x, y is -1/7. Okay, so that would be your y-intercept. The other one doesn't exist because if you put a 0 here, -1 cannot be equal to 0. These are your asymptotes. It's very similar to that problem. Now, this problem is x2 minus 16 from the formula of a2 minus b2, the difference of two perfect square, is x minus 4 times x plus 4. So for domain, there are two numbers that you must exclude. Domain is all the numbers except these two. Okay? Now, when you put 0, y is 0, or if you put y 0, x is 0. So x and y-intercept both are the same thing because the function just goes from one point. Now, we're asymptote. One asymptote is these two, 4 and -4. And how do I find the other asymptote? Look, the power of x is 2, the power of x is 2. So y is 1/1 for horizontal asymptote. Remember, if these two power are equal, then you take the number of 1/1. So there are 2 vertical asymptote and 1 horizontal asymptote. See, this is a horizontal asymptote. And the only intercept is 0, 0 is right here. First, you have to factor that. Domain is all the numbers except this. This is very similar to that. These two are also vertical asymptotes. And the other one, look, power of x is 1, power of x is 2. So x-axis is your, or y equals 0. Y equals 0 or x-axis are your other asymptotes. I said it here. Y equals 0 or x or x-axis are your horizontal asymptote. Your horizontal asymptote is this. Since there are so many pages, I don't want to have a long video. That's why I go through the pages quick. But you could always pause it and watch the graph. Okay. Now, this is interesting because when you factor the bottom and the top, do not simplify and then say the domain is this. No, for domain, you must consider both numbers. But when it comes to find the x and y intercept or horizontal vertical asymptote, then you should simplify and work on these equations. So remember, for domain, you must consider both -8 and 6. And in this case, power of x is 1 and 1, so y equal 1 is your other asymptote, which I showed here. Horizontal asymptote is 6, vertical asymptote is 1. Very similar. Denominator is that. Then when it comes to finding x and y intercept, simplify and just look at this. Now, what look, this is not a rational function anymore. Why not? There is no denominator. So this is just a straight line. Rational function means you have a denominator and there is a letter, or like in this case, t, but it's not. After I simplify, I come up with an equation that doesn't have a denominator. So this is equation of a straight line. Which is this one. Denominator x cannot be 0, that's domain. And when you put 0 here, is undefined. When x is 0, so this should be the other way around. So here should be, I'm sorry, I have to correct that. This is y equals 0 and plus or minus 3. So on your note, you need to correct it. Now, this is a case that you do not have horizontal or vertical asymptote. You have a slant asymptote. And how do I find that? By taking x2 minus 9 over x. When I break it into that, this is your equation, y equal x. So this is a case that you don't have vertical or horizontal asymptote. You have a slant asymptote. And to do that, you could take the top one and divide by this. You could use it like that. These pieces like that, or you could just use the long division. See, remainder is -9. So you could write this as x2 minus 9 over x is x minus 9 over x. This piece, which is that, when you divide, this is your slant. If you understand it in the next example, it's better. Look, like here, how do I find out this 3x? First of all, you don't have any x and y intercept. So how do I come up with a slant asymptote of t equals 0? You could either do it this way, break it, or just divide, or just take 3x2 plus 2 and divide by x. And that gives you that part, okay? How do I find this one? You have t plus 3. Domain is all the numbers except -3, and -3 is also your vertical asymptotes, okay? But you don't have horizontal asymptote, but you do have a slant. How do I find y equal 3 minus 3 or minus t plus 3? By dividing. See, because the top, the exponent at the top is greater than the one at the bottom. In that case, you always have a slant. So how do I find it? You could just do your long division method. This piece is your other asymptote. This is your slant asymptote. And you know how to graph y equal minus t plus 3, right? If you want to graph it, just come up with some arbitrary numbers, like 2 numbers. So let's say this is t. T equals 0, y is 3, t equals 1, y is 2. See, you could graph this. That's how to graph this one. A slant asymptotes. All the same, look. Because the power of x at the top is greater than power of x at the bottom, then you do have slant asymptote. Okay? But you do have two vertical, one is 0 and 9. See here? But 0 and 9, you consider as a domain, but here they cancel. When it's canceled, the only thing left is x. So the only asymptote is x equals 0. X equals 0, which is your y-axis, okay? So you have this, x equals 0, and also you have this slant. Same thing here. One asymptote is 7, and the other one is a slant. You have it here.